here. Okay. And I would like to start with what Bill Gates said when he was addressing newly graduates in 2017, I think it was. And he said that if he was his age, or their age, sorry, what an envy, what he wanted to do, if he would like to change the world, was to choose one of these three areas. The first one was artificial intelligence, because it's just starting to show us how we can be more productive and also more creative. And Paco before gave some ideas of how we can do that. The second one is energy. It's sad, but we are seeing how important it is to have clean, affordable, and reliable sources of energy, and artificial intelligence can help a lot with that. In fact, I'm going to talk a little bit about the relation between both artificial intelligence and energy savings. And the third one is bioscience, and Paco also gave us some examples, because using artificial intelligence, we are also having very completed maps of genomic and proteomic human genes and proteins, so we can go to a more personalized medicine, for example. Okay, there is another thing that I would like to show, and it is that until now, apparently, there is a direct relation between economic growth and the consumption of resources and the increase in production. So what we have now, at the same time, is that we need to grow economically. We are consuming more resources than we have. And the problem is that if we take a look, is this something that we can point? Yes, if we take a look at this graph with a representation of our ecological footprint versus the Human Development Index, there is no country here in the sustainability part of the graph. And most of what we call the first world is on a place which we cannot support any longer ecologically. Europe is not among the zones of the world that consume the most, but we certainly are not on the ones that consume less either. And so we need to do something, because most likely we are not going to be able to fulfill our ecological goals for 2030 and probably not for 2050. And there are a lot of ideas that try to say us that we need to take into account social and economical variables to try to fight climate change, among other problems. This one here is what they call the donut economic theory, in which we have, well, the green part represents an equilibrium between our well-being and the ecological situation of the planet. Any subject inside the donut lives in deprivation, and everything outside the donut has situations like climate change, consumption of resources that's not longer sustainable, and such and such. Okay, so this is the situation in the world, and what we are doing in Europe and in the world is try to set some kind of goals so we can fight this situation. In Europe, we have the European Green Deal to preserve our natural capital, achieve climate neutrality, and such, and United Nations has proposed sustainable development goals with these same ideas, and both are telling us that it's not only a matter of climate change, of affordable situations in energy and resource consumption, but it's something also that's integral and affects our education or our health. Okay, at the same time, we have artificial intelligence, right? So this is the technology that's driving us to this new future society. And here we can see the main hubs, which are China, we already know that, the United States, which companies are the most important by market capitalization in the world. And this situation was not the same like 40 years ago or more when the first 5 companies were not technological. And we can see also what happens with the companies in China as the control of Peking has pushed them below the first 10 positions. And what do we do in Europe? We don't have technological companies among the first 25. And so we try to position us with the things that we have. And the things that we have are talent, of course, and also this idea of having an artificial intelligence that is at the service of humans and it respects our privacy, but also is sustainable. So I think that there are 2 different phases on sustainability and artificial intelligence. One has to do with the development of AI applications that help us to be more sustainable. There are a lot of them, and I'll show a few. And the other phase is, at the same time, we are having, during the last years, larger and larger data sets. In fact, I think that the size of the data sets duplicates every 4 months or so. And so the algorithms that we have are more and more complex. And so we confront the Japan paradox. At the same time that we do something for sustainability, our algorithms are not longer sustainable, and our carbon footprint is high. So let's start for the brighter part, the AI applications for sustainability. And there are a lot of them. I try to emphasize the agriculture and cattle part of it, as these are the most important use of the soil in Europe. So this is an application that allows us to have an idea of the size and the type of fishes that we have in a trawl, so we can be much more sustainable in our fishing while we optimize our catch. And we can control, of course, many other things, like, for example, having data on the ships, on our fleet. We can be more. We can do predictive maintenance. We can control the fleet. And in our fish or land, on our sea, or land-based fish farms, we can control the food that we give to them, the conditions, and everything that we can think of. On cattle and agriculture raising, on cattle raising and agriculture, we have the same or similar situation. For example, we can have milking robots, GPS collars, virtual fencing that help us with cattle raising. And on agriculture, we can control the irrigation, we can diminish the herbicides and pesticides that we use, and we can do other things besides being more sustainable here, and is to attract younger people to zones that are not now underpopulated. In Galicia, we also use artificial intelligence, and in other places of the world, of course, for our wine production. So we can predict when we are going to have a plague or when to harvest, for example. And other companies can use it to be creative on the flavors that they put in the beer for the locals, for example. So we can use like padron peppers or barnacles to put those flavors in the beer and, of course, improve production. And we can do traceability of anything that we eat, from the soil or the animal to the consumer. So this helps also to improve our confidence in the sources that we are using for our food. And talking about rural areas and looking at the opposite, we can also use artificial intelligence for our overpopulated cities. So we can control the energy that we use or try to optimize it, try to find better ways of transportation, monitor pollution, try to monitor and obtain better ways of saving and producing energy and everything. And this is very nice, but there are things that we are forgetting here. And it's something that I would like to comment briefly, talking about my book, of course, about one project that we did in our research lab. And the things that we are a little bit missing when we work in artificial intelligence is that we measure things on accuracy, but we forgot another things. And is that the subject that's going to use the application, the artificial intelligence application, is a person. So we need to take into account the ideas of this individual. And I think that Paco also said something about this when he said that we should have a diverse team to work in our application, so we can take a look at the different aspects that are important here. Just to illustrate this, I'm going to tell you a little bit about this project. This is a European project that we, as already said, made in our research group, and uses agent-based model to try to improve the acceptability of certain social innovations. The project was bigger, but in our group we only modeled 2 places, which were Vitoria-Gasteiz and its superblocks, which is an innovation consisting on limiting different parts of the city and limiting the cars there, so there is no circulation inside. The cars that go inside get outside, and this allows for the recovery of the soil for the people. And also the other place that we modeled were the El Hierro Island, and I'm going to talk about this, although the situation is similar. So the El Hierro Island is the smallest one of the Canary Islands, and what they did there was the local government made a plan for having a source of renewable energy. It was a wind-pumped hydropower plant, and they would like that people like the innovation, so they were happy with it. And here is the point. We need to have the individual at the center of the model. So talking with the sociologists and psychologists of the team, they used social theory based on needs, and this was the idea that we used to model the central agents, which were citizens. So we have experiential needs, like, for example, I like to arrive to work quickly. I have social needs, for example, I would like to be accepted in my community, and I have values, like I would like to use a transportation that does not contaminate. for example. But we are not isolated as individuals. So we have our network of friends, our family, our neighbors, and the influence on what we think. And of course, we receive messages from the media, associations, the companies, the government, and we modeled this situation as communications. So we have communications between the individuals and their peers. And in this case, we have the possibility of sending messages on these aspects, economic sustainability, equality, participation, or receiving these messages. And as we relate with other individuals, and we don't trust all of them with the same strength, we weighted these bi-directional communications. In this case, in this other case, what we called critical nodes, the government, local media, and the company, neighborhoods, associations, etc., they only send messages to us, and they are weighted also. And how can we arrive to know all this data that we need? Well, we made a survey. The sociologist and the psychologist made the questions, and with them, we mapped every one of these questions to one of the needs that I just showed you. And we used the survey also to establish the size of the neural network of each individual and the trust that they have in relations. Created a population with the real citizens that answer the questionnaire, and we do need also to establish some artificial citizens, and we did that with constructing a decision tree using profiles from the questionnaires. So what we wanted to know is, are you against, are you in favor, or are you in doubt about the social innovation? And using census data like your education level, your gender, if you are employed or not, have children or not, decided had a decision algorithm on your final opinion. We implemented the whole strategy because the idea, so every single move that was done, every communication that was done during the time that the local government proved the social innovation was mapped. And with this, we obtain this situation in which we have in green the ones in favor, in red the ones against, and some graphs there. So this is nice, but it was not the final idea. Of course, we needed also to have several workshops with the stakeholders to decide on, do we have the appropriate model, and the model does reflect all the things that we wanted. What we wanted to do was to use artificial intelligence so we can help the politicians or the local authorities to devise policies that can increase the acceptability of the social innovation. In this case, and of course to derive more general ideas so we can implement similar things in other parts of Europe. In here, we can see, for example, what we call the baseline, which is the blue one. This is what really happened. Here there is an important reduction in the acceptability because the people in El Hierro thought that having renewable energy will affect economically their bill, and it wasn't the case. They were paying the same, although the sources were of renewable energy, so they were not happy. And what we tried was policies that increase the communication, so we have more communications between the local government and the people, and addressed their main concern, which was economic sustainability. And the gray one is the same, but instead of only addressing economic sustainability, they address the other two main aspects that that were important for the inhabitants of the island, according to the survey, which were prestige and environmental sustainability. So with this, we could, if implementing these policies, we could improve the acceptability from a little higher than 50 to a little higher than 70%, which is quite an improvement. And I detail this because we think that we have some challenges for AI and sustainability. The first one is an over-reliance on historical data in our models. So we do not only have this situation in which the data is larger and larger, and we have larger and complicated models, but we also have problems with bias. And some of them are very well known. Gender bias or other bias on race, for example, or religion or whatever. So we need to work on that. And other things that we need to work on that is that we might have uncertain human behavioral responses to our AI-based interventions. And sometimes this is difficult to model. And for modeling it, we need to take into account not only the engineering part of the thing and how interesting it is from the technological point of view, but we need also to have into account sociological interactions, economical reasons, and how we behave as individuals and as communities. There are adverse impacts of AI applications that we need to detect. And also two other things. The first one is that we are facing increasing cybersecurity risks. And in fact, this quantum computing, for example, is one of the technologies that we are waiting for so we can speed our machine learning models. Is true, but probably the hackers are also waiting for quantum computing to speed their attacks. So it's a double risk again. And we have also difficulties to measure the effects of our intervention strategies because we need to consider more things beside the technological points. We need to take into account not only accuracy, but other sociological aspects, economical aspects, and perhaps also the sustainability of the algorithms that we are developing, which is the second part of the talk. So in Europe, at least, we have several plans on the development of green algorithms, what they call green algorithms. And what is this? Well, this is the thing that I told you at the beginning of this talk, and it's the fact that as we are having larger and larger data sets, our idea is to have more complex algorithms, and we prioritize accuracy over other things, over efficiency, for example. And, well, I'm just mentioned this briefly, but one of the things that we need to do is work over the energy efficiency of the networks. And this is not only for, let's say, ecological reasons, but only for cost reasons. I would like to call your attention over this table. This is a summary of some results that have been obtained by these people of the article that I have on the lower part of the graph. And as we can see here, training and fine-tuning the parameters of transformer, for example, consumes like 5 times the fuel of a car in its whole lifetime. So what we are doing has a repercussion, ecological repercussion on the environment. And although it's true that we are doing things like trying to develop more efficient GPUs, using TPUs, reusing pre-trained algorithms and such, we should be aware of this situation so we can do something about it. And I'm going to tell you 2 or 3 things that we are working also in our lab. Well, until the most general situation right now is to make cloud computing. So around 80% of the computation now is done in the cloud, and this is the situation. We have our data that we record on sensors and actuators, and send the data to the cloud, and then we made the computation, so we have a lot of consumption also in the networks. And what we do now, or what we are trying to do now, is to compute at the edge level. So we do here local learning. So we have the local data that we have from our sensors and actuators, and we take advantage of these low capacity computing devices that we have on the edge, and compute here, do machine learning algorithms here. And if we want there to do collaborative learning, what we do is exchange model or parameters, but not data at this level, and there is no data sharing about the devices. This is a paradigm that is going to be prevalent probably in the next years, and it is expected to have the opposite situation in which 80% of the computations are done at the edge and not in the cloud. The market value is growing. A lot of companies are devoting their efforts to edge computing. There is no new business coming on, and the combination of this edge computing with 5G aims for a latency of almost 0, which is also a very interesting figure. And this is happening already in most sectors that one can think of, like the sector of energy, industrial, healthcare, agriculture, and everything. Okay. The other 2 things that we have here is data and code. And these 2, in the situation that we have now, it's what we call red AI. And what is this? This is the situation that I already mentioned. We have larger and larger data. We have more complex and complex code. And our algorithms are very accurate, but they have low transparency. That's the reason why. That is one of the reasons for the need of graphs to clarify some of these aspects. And also, we need to be aware that we are having a high carbon footprint in doing this, and that we need to arrive to new models in which the models are less complex, and we can generalize with smaller data sets. So if we center on the cost of executing the model on a single example, the size of the training data set, which influences the number of times we need to execute the model, and the number of hyperparameters, which influences the number of times the model is trained, an increase in each of these items makes a linear increase in the carbon footprint of our algorithms. And some of the recent ideas that we have with, for example, AutoML, in which the parameters are optimized automatically, increase this situation. Of course, it's red, but not dark red. When we have these complex algorithms, we can use them and for later retraining, not from the scratch, not working from the scratch, and that simplifies the situation. But there are two things that we are also working in our lab. One is centered on feature selection. Feature selection, as you probably know, is it's a pre-processing step that you can carry out because not all the variables that you have are needed for certain situations. So we can reduce the variables that we need. And in this case, we try to make feature selection also using low capacity devices. And for this, we need to change our standard way of calculation, which is a double precision floating point with 64 bits for a reduced precision. And in this case, we implemented a fixed point representation for certain type of feature selection algorithms, which are the mutual information-based ones. And briefly, these are the results. We can see this is the less favorable case, and this is the regular case for the several data sets that we tried. We can see that for the 5 top, 10 top, and 20 top features, 16 bits, it will be enough because we have the very same features that we will obtain with a 64-bit representation. If we go to classification, we have the same situation in which 16 bits, well, all of them are equivalent, but with 16 bits, it's enough to be on the higher side of the accuracy. And this is another case in which, well, this is project that we are just starting. And this is over the TripAdvisor platform. What we try to do is to give a user that that did not visit a restaurant, we want to offer this person the photography or the test that this person has written if he went there. And so it's related with the authorship. These are results for the picture part. And this is an example in which we have the, I can't see very well, but I think that there are like 20 or something photographs, and the author of the photograph that we are trying to identify is the author of the second one. So we are trying to offer this person the type of picture that he had taken. As you can see, most of them have the similar situations. Okay, these are the results for a smaller city like Gijón with only these test users, and these are the results for a bigger city like Paris. These are baselines, random and a centroid baseline, and this is an algorithm based on deep machine learning, and this is one based on matrix factorization. As you can see, the results are quite competitive between both. The matrix factorization, a much simpler algorithm, gets a little bit better results than the deep model on this small city, but gets worse results in the bigger one. In any case, the model is very competitive because we obtain accuracies that are slightly lower than the deep learning model, with very shorter training times in comparison, and with total CO2 emissions that are as you can see, much lower. So this is important. In fact, there are some recommendations on the publications that I have read that said that it's not important only to calculate the accuracy of our algorithms, but also the efficiency and inform report which is the consumption of CO2. And for example, in this case, this is a calculator in which you need to, they said that it depends on the location of the training server and the energy grid that has been used, the length of the training procedure, that's the number of hours used, and the hardware in which it takes place. And with this, you can not only report on the accuracy of your algorithm, but also on your carbon footprint. There are other things that we are doing, at least in Europe, regarding regulation, which is, of course, important. So in the ethic guidelines for a trustworthy AI, I think that we most reflect on this societal and environmental well-being, but we need to do some engineer with that part. It's not only blue bottom there, and with the risk levels of that are included in the proposal for regulation that the European Union has, the so-called Artificial Intelligence Act. So it's advisable to have a more future sustainable AI. And for this, we need some of the details that I try to comment. First, we need to incorporate multi-level views. That means that we need to incorporate accuracy, but we need to incorporate efficiency, carbon footprint, economic measures, social measures, and for that we'll need to have a diverse team in which perhaps sociological and psychological aspects need to be taken into account, because we need to have not only an artificial intelligence that's well done from the engineering point of view, but an artificial intelligence that's good for the people. We need to take into account that this process is a dynamic process, so some dynamic approaches are needed. Of course, the economic value considerations are relevant, as well as, I said, the psychological and sociological ones. And finally, we need to, we are talking about privacy by design, about edge computing, about a lot of things, but we need to incorporate in our design thinking the ecological idea also for a more sustainable AI. And that's all for me.
Hi, if anyone has any question for Amparo? Well, I have one. So it's very easy to read that it's expected that in the following years Europe will struggle to lose importance in the global affairs and global economy due to the two blocks having a technology advantage, and especially in this field that we have set now in AI and chip development and deployment of these kind of technologies on the cloud. So they are dominating. So how do you see developing trustworthy AI for Europe in the following years? Do you see it as a competitive advantage, or do you see it as a burden that's going to even slow us down more?
It's complicated. The question is not easy. I think that the same thing happens a little bit with what we were discussing, the regulations, the RGPD regulations about privacy of the data and everything. At the beginning, I remember that we were, the three of us, Paco, you and me, in Big Data Space. And the idea was that Europe will be losing steps there, because in other regions of the world that idea of privacy was not that important. Perhaps the next years come these scandals, let's say, with Facebook and Amazon and all the algorithms that they used and that were not very private and that were reusing the data of their customers for other things. I think that perhaps this is getting more important, and I hope it is that way, because we cannot lose the idea that we are developing tools for persons. And for me, this is the point also. So it's not a matter of are we losing step, are we behind on our developments? Because perhaps the developments will not take care in Europe, will not take place in Europe. But will the idea is a seed for other places of the world? I don't think that for China it is, but I hope that for other countries it will be. I don't know if that answers your question, but it is very difficult.
Well, with GDPR, it was the same, right? It was adopted in Europe, and everyone criticized and said it was going to be a disaster and a slowdown. And 2 years later, California is putting the rules, and they are realizing actually we need to do that. But actually, since we developed GDPR and everything with GDPR in mind, we didn't have to do anything at that point. We were already having that in mind. So I was thinking all these regulations are carbon footprint. It's the same idea. Mm-hmm. If you start developing things in the right direction, it can become a competitive advantage down the road, even if in the short term it looks like a crazy idea. It happened the same with Facebook and all these services that leverage AI. There is a loss of confidence, and that loss of confidence also leads to loss in capitalization value and profits, because if people lose confidence, you lose business as well. Whereas maybe your growth would be slower if you take the steps more carefully. Maybe it will be more robust. So maybe Europe can be considered as competing with giants that maybe have a support that is not as strong as we believe if they don't take these measures in time. So that was my reflection.
Yeah, I think so. In fact, in the previous talk that Paco gave, I think these knowledge graphs go also in that way. We are, I think, going to a more transparent algorithms, something that we can see and interpret. For example, working with the psychologists and sociologists, this is our second European project with them, we finally end up having to do like decision trees or some kind of machine learning that they can see what is there, because they want to check if what happens in the system has a reflect with their theories. And all of them are not from the same schools. I mean, we have sociologists from different countries. So some of them, believe in the norms theory, others believe in the social communication, and others believe in other social theories. But all of them find something that reflects what they think and how they think things should go in these decision algorithms. And they need to be transparent, because if not, they don't trust them really. So it's like Paco said before, they want to know what happens there and check. And sometimes they discover this 20% more that they didn't know, although the 8%, the rest, 80% is something that's transparent for them. So they tend to trust more this 20% that they didn't see before.
Any other questions?
I was curious about in the Canary Islands, is it San Hierro?
El Hierro, yes.
So the election baseline was 51% around there.
The acceptance rate, yes.
Unfortunately, in the United States, that would be an overwhelming election. It's always so close,
See, but the graph started, the problem was they accepted before, but because they thought it will be more affordable economically. So when they saw, in fact, there is a drop on the graph. And so when they saw it wasn't, and there were some articles also on the local newspapers, there was a big drop in acceptance. And this was what we tried to anticipate. So what can you do if this happens? How can you identify which are the values for these people, which are the values that are important for them. So it's not only important to the quantity of money that you pay, of course, in the bill, but there are other things important, like the prestige of the island. In fact, the El Hierro Island is I think is the first isolated territory in Europe which has been able to be independent, to fulfill their consumption just using renewable sources, of course, at certain times of the year. And they have also, the campaign that we advised was also based on health and education. So they saw that it's more affordable. It is not more affordable exactly, but this savings of money can reflect on your health, on how do you feel in your island, on the prestige that it has, everything. So it attracts more people for visiting, things like this.
Oh, fantastic. So it's more of like a long-range planning then, not just the immediate win, but what happens after.
What happens after?
Yeah. So I mean, it's not just that. Well, the AI application then is you can come up with scenarios of how to answer backlash, for instance, that will come up, or other considerations will happen later on after the election. I found it interesting that it's more of a long-term planning.
Mm-hmm. Yes, and it's something that you can try to implement in other cities. So you can have an idea of which are the values, because, for example, we try to use the same type of models in other places, and they have different values. So you need to adapt your policies to the values of the people who live there.
Any more questions?
Thanks for your talk. As someone who believes in donut economics, this has been very heartening to see that there's a lot of research in making AI more sustainable. So as a startup founder, right, in terms of dealing with big tech companies, there's this double-edged sword where we're competing with them, but also we're using their cloud technologies. And they'll always have more money to have faster, better AIs. And so my question to you is, have you seen sort of like smaller companies or startups, how do they think about sustainability in AI? And what can we do as small companies when, really it's not up to us, it's up to the cloud providers, or it's up to the academics to figure out these solutions? Like, is there something that we can do to help make AI more sustainable or further along the research?
You mean, I'm not sure if I have understood. You mean if you want to develop more sustainable algorithms, can you do something to say we are more sustainable and we obtain the same results or similar?
Yeah, or what can small companies do beyond, building their own algorithms? Is there something that we can do sort of more collectively? Is there something that we can do in the kinds of cloud providers or technologies that we use? Or have you in your research, have you seen startups and small companies sort of respond positively to sustainability efforts in AI, or do they just say, it's not my problem, the cloud provider should fix it, technology should, academia should fix it?
It's a difficult question also. One of the recommendations that I'm reading several works on this. One of the recommendations that they do is for everyone to be aware of this. We need to tell the people what we are really doing, because we are having an important carbon footprint. That's not something that everybody knows. So one of the ideas they say is just you need to publish which is your carbon footprint for your algorithms. So if the companies start to publishing how much are they contaminating, let's say it that way, of course the small companies can do things, because if you are more sustainable and you cooperate together, you can develop algorithms that are more sustainable and offer that alternative, I think. I don't know if that's an answer for your question, but as I said before, it's something that's valuable. for knowing, for trying to solve a problem, first you need to know that you have a problem. And I think that this aspect of contamination or of the machine learning algorithms is something that most of the public does not know. And so we need to be more efficient in general. And there are ways of doing it. There is people working in other architectures, like neuromorphic architectures, or this quantum computing that can speed algorithms and be more efficient. We can take into account, because sometimes when you have critical applications, accuracy is very important. But there are others in which you don't need to push this 1% more, because it's not worth it. At the same time, you are having a carbon footprint which is very high for almost nothing, and that's a point, because most when I was showing this picture on data and code, I was reading also some publications on how much effort do we put on improving our code, which was most of the papers that you read are on improving a little bit over the previous results. Very few are working on the improvement of data, which, curiously, when you improve data and you have big quality data, although smaller, you obtain much better accuracies also, because the quality of your results improves. However, if you look for papers, there is very few that work on the data side. And it's the same thing with this sustainability. There are very few papers that you can find on. It's important to go on this race on this very few percentage of improvement. Accuracy is nice, but it's not the only thing to do. And I think that this is the message that we need to extend, because there are things that need to be accurate, for example, in medicine, but others are not so critical. So you don't need to follow this career and be less sustainable, because there is no point on it.
Yep. So yeah, I think maybe we can develop the answer a little bit more with one of the slides you have, but it maybe has slipped. So in your results on the recommendation, you show that in a smaller city with probably a more simplistic data problem, like it's the same problem, it's recommendation, but for whatever reason, no, it doesn't matter. In one city it was easier to solve, and it was solvable with a simpler model. And in the other one, actually, the simpler model was almost matching. In the case of Paris, it was almost matching, but it was less accurate, right? So I think as a founder, that's where actually you can show leadership and you can take that decision, because it's like, is this 1% more in a market that maybe, a city of Paris, I may have a good economic revenue from that. Is that worth it or not? That's probably the kind of things, like as a founder, you can add into your agenda when you're taking decisions and leading teams, right? Or maybe you can decide, okay, we're going to take the extra DevOps effort to have like 2 kinds of models in production, and if the simpler model works for like 80% of the cities, and only in the big cities which are really complex, we need the really hardcore model, we're going to take the effort of DevOps for the sake of sustainability of our operations and CO2. So I think that comes to leadership. I think there is room for having leadership on that aspect as well.